Okay, the security of blockchain strongly relies on the SHA-256 or hash functions. This is a best one of the best platform where you can learn the basic concepts of blockchain, like hashing and how hash relates the blockchain and blocks. So let's start. Okay, hashing, that means any data is converted into a fixed length text or fixed length string of numbers and characters, and even a minor change, even a minor change changes that particular hash of that entire data. That means there is no relation between the hash of even if I change a single digit, the entire hash is randomly or avalanche. This is known as avalanche effect. That means no relation between the any. It's very difficult to figure out how the things are changing. Okay, and this hashing is a core concept of blockchain. Okay, let's understand how. Okay, this is a block. We can say it's a one first block, or we can say it's a zeroth block. You can see if I change any data, even the block number in that particular thing, this becomes pink one. That means invalid. If I put back the data, it again becomes green. That is, it is satisfying the hash which is required. Okay, this is a nonce, and as I change any data, okay, data, this is blockchain, or you can say this is blockchain. You can see the hash is also changing, the block hash is also changing, and the block becomes invalid. To make it valid, look, the focus please focus on the number of, okay, block number, sorry, hash number. If I mine, that means I change the number of nonce from 1 to maybe some infinite finite number. That makes that hash according to the requirement. There's a difficulty level of that particular blockchain. Okay, again I start mining, and look, 34872. Now that's my block becomes valid, and now the format of the difficulty is set, which is 40 starting zeros. Okay, again I can mine. Now the same thing, the same value. If I even change block a dot, a full stop I placed, this block again becomes out of sync. That means the format, required format, is not there. Again I need to mine, means change the number, block number, sorry, not nonce, I need to change the number once used once. Okay, so I again change, I start from 0 to that particular number, and 7830 is a number which is combined with this block data, nonce and block, and that will create hash of this format. Okay, let's move to blockchain. This is a blockchain format, how different blocks are related. Look, it's a previous block, that means is a this for this particular demo, this is a genesis block. Okay, and because this point to the 000, that means there is no previous block. Okay, and the similar way, this hash is stored in the next block. That means the block 1 and block 2 is related by this hash value. This is the link between the blocks. Okay, if I even change, and the similar thing for block 2 and block 3. Okay, if I even change even a dot or place a single a inside it, the entire block, look, the block before I tampered remains same or safe, but the blocks after the tampering becomes invalid. That means there is a no linking now. Actually the block 2 is linking block 1 and block 3. Okay, block 2 is actually linking block 1 and block 3. If I change the block 2, there is a no linking between block 1 and block 2, because the format, the hash has been changed. Look, the format, that difficulty level, or that the format required for hash is not there. So similarly, same thing happened with all the blocks after that. They becomes out of sync. Okay, even after mining this particular block, even if I manage to mine this particular block, the rest of block becomes in sync or out of sync, or they become invalid. And this is the biggest difficulty one attacker faces when he try to tamper with any block stored one node. Okay, this is just problem when the blockchain is stored in a single node. Let's see this problem when the blocks are stored in a different nodes or in a distributed manner. Okay, Suppose there are block A, sorry, peer A, peer B, and peer C. Okay, the same block is now blockchain is stored in a different places or different users. If I try to change mine, suppose A is me, B is my friend, and C is his friend. If I try to change my blockchain, my block, and somehow I manage to mine it, okay. But the problem is other blocks becomes invalid. And now if I share this blockchain, share this block with my friend, he can easily detect that the blocks has been tempered, because the previous block previous hash may be match, the same hash is there, but the hash of the block is not matching. Even though the format 000 is matching, but the hash is not matching. Then the B again checks with his friend, and he found that the block of my friend and the block of B and block of C is matching. What he does, he try to force me and say that you have altered, or your block is not matching with us. And in this way they can easily say that some tampering has been done, or they can easily detect the tampering. So okay, now let's see it in a bigger picture, or with some more transactions. Okay, here the same there is same scenario. There is a peer 1, peer A, peer B, and peer C. All of them have same transition, same blocks. Okay, let's suppose at block 3 peer A try to change this transaction. There are several transactions, and he tried to change Madison to Jackson, $5 transaction to $5.3, $5.30. Now you can see the transaction, the block becomes invalid, and the blocks after that also become invalid. That means it is showing that some tampering, he's trying to tamper. After that, he's trying to mine that his block. He mines and store it again. He was very clever, and he somehow managed to mine entire his blockchain. Okay, entire his digital ledger. He's try to or he is able to mine it, and he's make his blockchain a valid one. But after that, after he called his friend Pierre B, and he asked him to update it. What happened? What will happen? The B will see, okay, your block and my blocks are not matching now. Okay, because A has altered something. Then the blocks of block 3, your block 3 is not matching with me. That means in your blockchain, Madison is sending Jackson at 5.30 dollars, but in my case he is sending just $5. Okay, then B consults to the his friend or C, peer C, and he again asks him to check. This process known as sometimes validation. He is trying to validate that block is actually a good block, or it's a just tampered one. He found that the ledger of B and C, or his ledger and C's ledger are same. Then he can easily ignore the updates from the peer A. That means you can see now, if B and C ignores the ledger of B, ledger proposed by A, the entire hard work or computation done by A becomes useless. Okay, as the as this process is very time consuming and computational consuming, the entire work of A becomes useless, and this is a big loss for financial loss and a loss of trust. Now B and C maybe understand that the A is no longer trusted one. Okay, so they can just put him out of the network. Okay, this in this way they can detect the malicious node in that particular network, and this is how blockchain makes the network safe. Okay,